So, you've probably used generative AI. We all have. But have you ever stopped to think about what really happens after you hit enter? Well, today, we're going to pull back the curtain on the absolutely incredible technology that makes it all work.
I mean, every day, right? We're all interacting with these amazingly powerful generative AI models, whether it's for writing an email, creating some incredible art, or just settling a bet with a friend. Because that one simple click, it kicks off this whole chain reaction of super complex computations that are, believe me, anything but simple. So today, we are diving deep into this hidden world of what's called serving large language models, or LLMs. And we're going to uncover the brilliant open source tools that are making all this power accessible to, well, pretty much everyone.
Okay, so what does it actually mean to serve a model? Put simply, it's just the process of taking a model that's already been trained and making it available for people to use. You send it a prompt, you get a response back. Sounds easy enough, right? Well, that's pretty much where the simplicity ends.
Yeah, serving an LLM isn't as simple as just putting a file on a server. You're up against three major hurdles, and overcoming them is honestly one of the biggest challenges in computer engineering right now. First off, these models are just massive, absolutely huge. A popular model like Llama 3, the 70 billion parameter one, can need something like 150 gigabytes of GPU memory. To put that in perspective, that's more memory than you'd find in a dozen high-end gaming laptops combined. And that's just to run one single copy of the model. We're talking incredibly expensive, specialized hardware. Okay, hurdle number 2, they are wicked complex to run. These models generate their answers one token at a time, and you can just think of a token as a piece of a word. It's this slow, repetitive loop. It generates one token, feeds it back into itself, reprocesses everything, and then predicts the very next token. So if you ask for a long essay, you're forcing it to run thousands of these really expensive computational loops. This whole process of generating a response, it's called inference, and it is, by its very nature, slow and just eats up resources. Which brings us to our first key solution of the day, a super high-performance engine from some brilliant researchers at UC Berkeley called vLLM. It was designed specifically to tackle this speed problem head-on. Now, the biggest single bottleneck in all of this is managing something called the KV cache. The easiest way to think about it is as the model's short-term memory. As it's reading your prompt, it stores all these important mathematical relationships between the words, so it doesn't have to recalculate them from scratch for every single new word it generates. And here's the crazy part. This is what the vLLM researchers discovered, and it's a shocker. They found that the traditional systems for serving these models were wasting a staggering 60 to 80% of that precious, expensive GPU memory, all because of how inefficiently they were managing this KV cache. Just gone, wasted. So how does vLLM fix this? With its first big innovation, page detention. It's a genius idea they borrowed from how computer operating systems have managed memory for decades. It breaks that big, clunky KV cache into small, easy-to-manage chunks or pages. And this one simple but brilliant change reduces that memory waste to almost nothing, sometimes as low as just 4%.
The second big idea is continuous batching. See, old systems would take a group of requests, a batch, and they'd have to wait for the very last one to finish before starting the next group. This meant the GPU was just sitting around, idle a lot of the time. But vLLM, it dynamically slips new requests into the queue the second there's a free spot. It keeps that expensive GPU working nonstop and just blows the doors off the competition in terms of throughput.
Okay, so vLLM makes a single model run incredibly fast. That's awesome. But what happens when you need to serve a dozen different models to thousands or maybe even millions of users all at the same time? Now you have a problem of scale.
And this is where our second hero, Kserve, comes into the picture. The best way to think about Kserve is like an air traffic controller for all your AI models. It's a production-ready, open-source platform that's built on Kubernetes, and it's designed to handle all the messy, complicated operational stuff of deploying and scaling models in the real world. And because it leverages Kubernetes, which is kind of like the operating system for modern cloud applications, Kserve gives you all these powerful enterprise-level features right out of the box. It can automatically scale your models up and down with traffic, it can safely roll out new versions, it balances the user load, it even caches models so they start up instantly. Kserve is also really flexible. It gives you different ways to deploy your models. For instance, there's a serverless mode that is incredible for saving money because it can automatically scale your models all the way down to zero when nobody's using them. You only pay for what you use. But if you have a really complex setup, you can use raw deployment mode for maximum fine-grained control over everything.
So let's recap. We've got vLLM, a specialized tool for pure inference speed. And we've got Kserve, a specialized tool for operational scale. Now the real magic, the key insight here, is that they aren't competitors. Not at all. They're actually the perfect collaborators.
And here's how they perform this elegant little dance together. A user sends a request. Kserve, the air traffic controller, intelligently routes that request to a running model or spins one up automatically if it needs to. Then, inside that running instance, vLLM acts as the supercharged engine, using page detention and all its tricks to process that request at maximum speed before firing the response right back to the user.
Now, this powerful combination of specialized, open-source tools, it's more than just a cool piece of engineering. It's actually fundamentally changing who gets to build and deploy powerful AI applications.
You know, as literally millions of apps start to bake AI into their features, the biggest challenge and the biggest cost isn't going to be training new models. That's a huge upfront cost for sure, but it only happens once in a while. The real ongoing challenge is going to be efficiently and affordably running those models for billions and billions of user queries. That's inference.
And that is the key takeaway here. By solving those two core problems, the problem of speed and the problem of scale, open-source tools like vLLM and Kserve are totally democratizing AI. They're giving everyone, from individual developers to startups, access to the kind of powerful, efficient infrastructure that used to be reserved for just a handful of tech giants.
So this leaves us with a final, really exciting thought. Now that the power to build and serve AI at a global scale is in more hands than ever before, the next world-changing idea, the next great AI breakthrough could truly come from anywhere. And, who knows, maybe even from someone watching right now.